Pull-down reference circuit faults can trick you into chasing the wrong part. In this lesson, we'll show you how one voltage drop in a shared reference path can mislead scan data, fool voltage measurements, and trigger fault codes across multiple sensors, even when the parts themselves are fine. You'll learn repeatable diagnostic steps that lead to the real cause. Before a fault, the ECU sends a stable 5-volt reference signal to multiple sensors, each using that voltage to produce a reliable signal. But these branches are tied together. If any sensor or wire pulls the reference low, it drags every connected signal down, confusing the module and creating misleading data. The ECU decides if a sensor value is believable by comparing it to related PIDs or expected ranges. With a pull-down on the reference, several signals can become low together. The ECU's plausibility logic spots when this doesn't fit expected operation, but it can't tell whether the sensor, wiring, or reference itself is at fault without more evidence. To prove a pull-down fault, measure the 5-volt reference at each sensor while the circuit is connected and loaded. With all branches connected and ignition on, you should measure close to 5 volts at each sensor's reference pin. If you see significantly low voltage, like 2 volts, 1 volt, or even 0, you have found proof of a shared circuit problem. Compare your reading to ECU pin voltage if needed. Remember, test with the circuit loaded, not unplugged. Choose the first useful test from symptom, code, and data evidence instead of guessing. Once you confirm a low reference voltage at multiple sensors, you need to isolate which branch is pulling it down. Unplug one sensor at a time and monitor the voltage. When the reference voltage snaps back to normal after unplugging a particular sensor or harness leg, you found the source of the pull-down. Only after this step should you suspect a specific part or wire. A scan tool may show multiple low PID values or a low voltage code, but replacing the sensor or wiring based solely on that clue leads to mistakes. Scan data is a good starting point, but always confirm with loaded circuit measurements and branch isolation. Skipping these steps may result in unnecessary sensor replacements, repeated codes, or even new symptoms. Here, the technician compares the seen evidence against the next test instead of repeating the same generic diagnostic reminder. Use this step to name the condition, the observed data, and the confirmation path that separates this scene from the rest of the workflow. This scene narrows the decision to one specific measurement or clue, then points to the next action that confirms or rejects the suspected fault. A pull-down fault in a sensor reference circuit can trigger error codes, drop multiple signals low, and waste time if evidence is misread. Always measure voltage under load, isolate the responsible branch, and trust your process, not just the scan tool, before replacing any part. Thank you for watching. Use these diagnostic steps anytime a signal or sensor circuit drops low, and you'll find the real cause without wasted replacements.